Alrighty, so in this video, I'm going to cover some basic physics, laws, and terminology. So we're going to start off with kinematics and dynamics. So breaking down these words, kinematics is Greek, and kinemat means motion, dynamics is Greek as well, and dynamis means power. So kinematics deals with the evaluation of the motion of objects, and this is different from dynamics, where you're analyzing the forces which cause the motion of an object. Alright, so breaking this down a little further, so kinematics is how, so in what manner is the object moving, and dynamics is why, what causes the object to move. So on the side right here, we have a model showing the kinematics versus the dynamics of this robot. So as you can see on the left, we're seeing how the robot is moving. Is it rotating? Is it moving up or down? Whereas on the right, we can see the force that is influencing the robot to move in a certain manner. So the weight it seems to be holding would cause it to have some stress, pulling it downward. Alrighty, so next we're going to focus on Newton's laws of motion. So his first law is inertia. So the direct definition of this is: an object at rest remains at rest, and an object in motion remains in motion at constant speed and in a straight line unless acted on by an unbalanced force. So the inertia is an object's resistance to changes in motion. So the more mass, or the amount of matter, that an object has, the more inertia it will have. So we just have an example of a hummingbird, which is going to have a much lower inertia than the semi-truck on the right. So just a reminder, mass is different from weight. Weight is dependent upon gravity. So an example I have is that someone who weighs 100 pounds on Earth is going to weigh 16 pounds on the moon, because the moon's gravity is 1/6 of Earth's gravitational pull. So, whereas the mass does not change based on location, since the amount of matter in an object is constant, so it's remaining the same. So here's an example of inertia. So you have a kite, and when the wind changes, the motion of the kite is going to change. So this change in direction of the wind is the unbalanced force, and the kite's mast resists this force initially. So this is called the inertial delay. However, it is going to then change its speed and direction after this initial delay. So Newton's second law is force, which is the acceleration of an object depends on the mass of the object and the amount of force applied. And then here's the equation where force, which is mass times acceleration, is equal to the change in momentum with change in time. So the physical measurements of force are vector quantities, which are identified by two characteristics: magnitude and direction, where scalar quantities only have magnitude. And then on the bottom, we can see the two vector examples. So the direction is the point in which the vector is going, and then the magnitude is the length of the vector itself. So vector quantities include displacement, velocity, acceleration, momentum, force, lift, drag, thrust, and weight. And scalar quantities include length, area, volume, speed, mass, density, press, temperature, energy, entropy, which is basically just the energy dispersal and unavailability in a system, so a thermodynamic system, and then work and power. So here's an example. So you have a sled with 10 pounds, and your friend has a sled with twice the weight of your sled. So that's 20 pounds. So your friend will require twice the force to push their sled at the same acceleration that you are pushing your sled. And then finally, Newton's third law is action and reaction. So whenever one object exerts a force on a second object, the second object exerts an equal and opposite force on the first. So for every action in nature, there's an equal and opposite reaction. So our final example is when swimming, you're using your hands to push the water backwards, and in response, you are being pushed forward into the water. So our action is swimming, and our reaction is being pushed forward. So that backwards hand motion is the action. So, overview of Newton's laws. Inertia is the first law, force is the second law, and the third law, action and reaction. So a mnemonic to help you remember this is Isaac favors apples and raisins, or IFAR, inertia, force, action, reaction. Here are the sites that help me conduct some of this research. And thank you for watching this video. I'm planning on making some new ones where I will dive in a little deeper to some of the concepts and terms that we covered in this video.